Hey folks, how's it going? This is Mr. Murray coming to you with a breakdown of the Hypothesis Lab test practice. This is going to be the first of potentially maybe 2 or maybe 3 practice assignments where you're actually going to take data or like a summary of data that was collected. And I've actually printed out the Google Doc that you had access to for reference. It is this doc right here. What you're going to be doing is you're going to be using that to fill out a Google slide that's very, very similar to what you're actually going to be doing for your lab. So the purpose of the assignment is to give you a sense of literally, more or less, with a little bit of exception of stuff related to like, your favorite things to do for summer, which I don't think, you guys really need that practice with, but to really get a sense of how you're going to go about filling in the slides when it's time for you to do your data. So if you can really master how to do this, then you're going to be in really good shape when it's your turn to actually do your lab. And so, because I'm just trying to ensure, this might actually be the last assessment of the 2020-2021 school year. So we really want to capture as many points as possible. And my hope is that this will help you in kind of avoiding making those little errors that take those points away. Okay, so at this point, once we get to the point where I'm putting out the solutions video, I'm not going to be taking submissions for this assignment because, again, the solutions are out. It's not going to present very much like learning value at this point. What I can say is that I will grade the assignment based on completion and effort. So if you made a strong effort to complete every single slide, I had people emailing me or putting comments, private comments in Google Classroom. That's great. I think I can find a way to give you full credit. Going forward, especially as we get to the lab, there's going to be a stronger emphasis on correctness. Okay, so that's partially why I'm doing a solutions video today. Okay, so to do this, as I've been emphasizing in class, you do need to have access to 3 handouts. That's 4.3, 4.4, and 4.5. So hopefully you have access to those physical copies. If you don't, I do encourage you to go to Google Classroom, to the classwork section, scroll down to important course documents, and open the binder checklist. Here's the binder checklist right here. And so here are 3 documents, 4.3, 4.4, 4.5. So I'm going to open 4.3 so you can see what you're going to need. What you want to do is all you're going to need from 4.3 is the standard normal table. Now, I do understand that this one actually might not work out to have come from the standard normal table. I do understand that. And so I am sympathetic to that. And if that's something that happens in terms of your lab, we'll work on it from there. We did have people who are very resourceful and looked online, and that's completely fine. I appreciate you letting me know about that. But in any case, what you want to do, not the class histogram, we want the notes. Okay, so you want to go to Unit 5, Lesson 3 notes. You want to have access to just the only thing you're going to need is the standard normal table. Remember that this only tells you what is below that particular z-score. So I'm going to just annotate this real quick. This only tells you below. In other words, it's only going to work if you're doing a left-tailed test. If you're doing a right-tailed test, you have to use the trick of doing either the opposite of the z-score. So for example, instead of doing 1.1, negative 1.1, or you do 1 minus whatever standard normal value correlates with your z-score. If you're doing a 2-tailed test, you just take whatever you get from your z-score, like your value in this chart, and you basically multiply it by 2. Okay, so I just want to make that clear because that is a little bit of something that we saw coming up. So I want to make that clear so that there's no confusion when we get to the point where it's being based on correctness. Okay, so I'm going to clear that out. Next thing I'm going to do, we want to take a look at handout 4.4. Now there is a blank version. If you need it filled in, I encourage you to go to, see how I just clicked on the key, and there's actually a key, and I'm just going to move this so it's in order, already filled in. This is everything you need to know already filled in. This is literally what I used, what I was looking at when I was putting up the notes that we did in class. So you don't need to even have had, you know, if you lost it, if you weren't here, whatever, just click where it says key, open the document, you got a filled in version. Finally, you're going to need access to handout 4.5. That is the Phantoms walkthrough. This is really important because it contains a couple things, some important formulas, reminders, and your slideshow for your lab is going to follow this steps exactly in order. So one side's going to be P, then H, then A, then N, then T, then O, then M, then S. It goes literally in that order as we're going to see. Okay, so again, you have the option of having the handouts up on your computer. There's really nothing that you even need to have written down. If you can have access to this on your computer, that should be fine. And what I like about that is students who are remote or students who are in person, maybe you don't have a printer, whatever it might be, you have access. There's nothing you need to have printed out. Okay, so what I'm going to do is we're now going to go to the practice, and I'm going to, again, I have printed out this document that you see here, and I'm going to be going through it step by step. I also have a TI graphing calculator. You don't need a graphing calculator. You can use Google. You can use a scientific. There's nothing that the graphing calculator does that you actually need for this lab. If you take statistics next year, you might look at other kinds of tests like t-tests that you will probably need a calculator to do, though Desmos is more and more coming out with tools where you can actually do that stuff on your computer. Okay, so let's jump into it. This experiment we did was about shoes. Don't get the blues, they're just your shoes. That was the really corny headline that I came up with. All right. So one thing to know is that this document that you had access to that I printed out follows what you're doing step by step. So this is actually be like an experiment that you do. And if you just go down the document after that horizontal line, step by step, it's going to track exactly what you're going to do on this slideshow. So it starts with Mr. Moray wants to study the number of pairs of shoes that students at Milton High School own. Okay, what I gather from that is that students at Milton, and I put the bold in myself, you don't have to put in the bold, students at Milton High School, that is the population that we are studying. Remember, parameter, population. When I do the blanks, my intention is for you to delete the blank and replace it with words. I think it looks a little bit nicer. If you could get in the habit of doing that, that's fine. I don't think it's going to make or break you, but it is something from like an aesthetic point that I'm looking for you to do. All right. So I have that done. I'm just going to make a little check that off on my paper. Mr. Murray thinks that on average, a student at Milton High School owns less than 6 pairs of shoes. Okay. So the purpose of my experiment was to study whether students at Milton High School had an average of less than 6 pairs of shoes. Okay. And you can, rephrase if you want, owned, etc. As long as it's clear what is the population, students at Milton High School, what is the parameter, pairs of shoes owned. Now, this basically implies that our claim is that the average pairs of shoes owned is less than 6. So let's go on to our hypothesis. And again, if you've had a chance to actually browse through the hypothesis test lab, you're going to notice that the lab that you're going to do for your final lab assignment looks almost exactly the same as this. Literally, the slides look exactly the same, down to the words that are on the slides. Okay, so hypothesis. Let's take a look at the hypothesis. Mr. Moray sets his hypotheses as follows. The average number of pairs of shoes is greater than or equal to 6. So this needs to say greater than or equal to 6. So I'm going to highlight, I'm going to copy or press Control C or Apple C, copy, and then I'm going to paste. And I'm going to get rid of that underline. So that says the average is greater than or equal to 6. The alternative hypothesis is less than 6. And remember, that is our claim. So basically, our goal is we're going to reject the null hypothesis. So if there's evidence to reject the null hypothesis, then what then is likely true is that the remaining or alternative hypothesis is then true. So our experiment is going to determine whether we have sufficient evidence to reject the null hypothesis. One thing you want to note, look at this reminder, the null hypothesis involves equality. The alternative hypothesis does not. Notice how there's a greater than or equal to sign in the null hypothesis. That is really important, okay? Okay, so it's all you need to have done for this slide. One other thing I want to note, go ahead and take a look. And I haven't been really pointing this out, so I'll go back to the last slide. If you make these speaker notes a little bit bigger, you can see examples and it tells you what you need to fill in. Okay, it gives you some help here. Okay, assumptions. Mr. Moret uses a convenience sample to gather a sample of 50 MHS students from which he finds a sample mean of 5 shoes and a sample standard deviation of 1.5 pairs of shoes. Okay, so I'm just going to highlight, this is where I'm at right now. Okay, all right, so how do we fill this out? So what does my sample mean? So first of all, we're always going to assume we have a normal distribution. If we don't, we can't use the standard normal table. In reality, do we really have a normal distribution? Well, we saw from our experiment with the dice rolling, we saw that at a sufficiently large number, the averages of things tend to approach a normal distribution. So because we're dealing with averages, it's possible, you know, it is a big assumption, but it is an assumption we're going to have to make. We're going to assume that the significance value, which I sometimes in class call goldfish because of how I write the alpha, we're going to assume a significance value of 0 and 5/100ths. We don't always have to use that. It's a pretty standard one to use. And again, that's the one we're going to use here and for your hypothesis lab as well. We're given a sample mean of 5 pairs of shoes, a sample standard deviation of 1.5 pairs of shoes, a sample size of 50 students, and we used a convenience sample to gather the data. So again, this is exactly how you'd fill that out. There's nothing more that you have to do here. Now, one thing I do need to do an edit, and I'm going to edit this in the final version because I made it 50. But notice how in the speaker notes, you use the survey data worksheet that you either distributed in class. Really, you could just have your 50 numbers. I said 50, so again, that's why I've got to adjust the speaker notes. But you just can write, you could put it in a Google Sheet, you could write it out on paper. I need to see 50 numbers or more, and I'm willing to offer bonus for more, that you collected by asking your population, people in your population, so it's students at Milton High School, and I got to see clearly those different numbers. When you get to the lab, you're going to type your data into OneVerstats. You're going to do OneVerstats. Maybe it be like a Desmos tool. You're just going to type it in, and the calculator is going to get the mean and the standard deviation for you. You're not going to do that. Your calculator is going to do that. Your sample size, you'll know that because OneVerstats will tell you, but also you'll know how many data points, like people you asked. All right. For the most part, we're going to have done a convenience sample, which is not ideal, but at this time, we just don't have the ability to really be able to choose from the whole list of Milton High School students. I don't have access to that. So other kinds of samples like clustering, simple random, stratifying, without the whole population and having access to that, to being able to break them into strata or assign them numbers and pick from numbers, other kinds of sampling methods are just not going to really be possible. And again, when we ultimately think about how we interpret our results, we'll have to take that with a little grain of salt, because the sample that we chose, because it's a convenience sample, might not necessarily be representative of the population. Okay. All right. Name of test. So name of test, here's how you know what you're going to do for your test. So remember, you have to look at your alternative hypothesis here. So what the notes tell us to do, if you look at the back, and you might want to make a little star here. Okay. You might want to make a little star here because it's going to be important. So what you're going to do is you're going to look at this page and this part of this page, and this says, what test do you use based on the inequality sign in your alternative hypothesis? So here, let me just clear that out, and hopefully you put your mark there. We have a less than sign. So our notes say when you have a less than sign, use a left-tailed test. You're not going to guess on this. That's why I gave you access to the notes, because I don't want you to memorize. I don't want you to guess. I want you to look at the notes. That's fine. There's no judgment here. I'm giving you the notes because I want you to use them, because these aren't, I care more about your ability to, again, interpret what you're seeing than your ability to say, which of these tests do I use? That's less important to me. So you're going to use, in this case, because it's a less than, our notes say to use a left-tailed test. You can bold it, you can color it. It just has to be clear. You can highlight it. It just has to be clear that you selected one of them and that you selected the right one. So in this case, a left-tailed z-test. All right, the test statistic is the next thing we're going to calculate. You might be wondering, what are these blanks doing? Okay, so for that reason, what you're going to do is you're going to go to your phantom sheet and notice how this sheet is perfectly tracking your slides, right? P, H, A, N, T. See how the slides each have a letter, and it has that yellow letter to highlight it. So same idea here. T, each box, each row of this table is going to give you exactly what you need to know to basically do that slide. The test statistic box is particularly important because you're going to need your formula for how you calculate the standardized test statistic, which in this case is a z-score. Okay, and again, the idea of this is it's kind of like this component of statistics is kind of like an application, like a more advanced application of like z-scores. So according to handout 4 or 5, our z-score is calculated by taking the sample mean, subtracting the population mean, and dividing by the sample standard deviation over the square root of the sample size. So our sample mean is 5, and you can even go back to assumptions if you may have forgotten that. Our population mean is the mean we were claiming that our population had. So we claimed that our population owned less than 6 pairs of shoes. So our population mean is going to be 6. Our sample standard deviation of 1.5. And our sample size, we're going to do the square root of 50. Notice how down below in the speaker notes, what does it say? 3 decimal places in your intermediate answer, 1 decimal place in the final answer. Remember that to use your Z table, your standard normal table, that is, it only works with 1 decimal place, okay? But to ensure the most accurate final answer for when we actually do that standard normal table lookup, we want to round in the intermediate answer, which is this second fraction here. We want to use as many decimal places as possible. So 5 minus 6, -1, we can leave that as -1. We don't need to say -1.000 because we know like that's it. So that would be like an exception. Now on the bottom, I'm going to go on my calculator. I'm going to do 1.5 divided by the square root of 50. And I'm trying to get a good, but my virtual background is not being my friend. What you should get is 0.212. 212. Okay. Now what I'm going to do is I'm going to go in and I'm going to do -1 divided by 0.212. I get -4.71. So we're going to leave it as -4.7. That is our standardized test statistic that we use to calculate the p-value. So here's the issue. Okay. And I take responsibility because, again, this is my test. So what you might remember is now what we do is we go to find the p-value. So the p-value, we need our standard normal table. Now the issue is our p-value only goes down to -3.9. 3.9 is the lowest you can go. And so basically you can see at 3.9, if I just annotate this really quick, you're basically at 0. And that's because at -3.9, if we look up here, the area under the curve is so little at that point that it's basically 0. Now, some people went online and they got like 0.000002, right? Really, really close to 0. And so again, that's something you might want to, we would consider when we actually go through the process of using your own data. It is possible that you could get a z-score that's a little bit like not on the chart. We may have to look that up. That's not the end of the world. Okay, it's fine. It happens. You know, it's not really something to, you know, really fret over. Okay, so now I'm going to do my p-value. So one thing I just want to note on this slide, go ahead and look at the speaker notes down at the bottom. Notice how it says how to find your p-value. So again, use the speaker notes. So use this, it says, use the standard normal table from handout 4.3. Remember that your p-value depends on what type of test you're doing. So if you're doing a left-tailed test, you look at the standard normal table, you're done. So you look at your z score, and this should really say your z score to be more clear, and I'll try to fix that. But in any case, you look at the normal table, you find your z score, whatever is in the standard normal table, that's your p-value. Okay, right tail test, you either do 1 minus that, or you take the z score, you do its opposite, and you look at that value in the table. Or if it's a two-tail, you take the z-score value from the z-table, so from the standard normal table, whatever corresponds to your z-score, and you multiply that number by 2. So you just have to, again, but it really matters what you did for your test, because if you don't do the right test, you're going to get the wrong p-value, okay? So what I had is I had some really great students look this up. It basically to 4 decimal places is 0. Someone looked it up and was able to find it's 0.00002. Basically 0.0000. For the purposes of comparing to a number like 0.05, 0.10, or 0.01, it's so low that saying 0.0000 or 0.00002 is not going to make a huge difference in terms of your interpretation. But again, I do really appreciate people taking the time to look that up. So that is our p-value. Okay, so now we need to know, is this going to indicate that we have enough evidence to reject the null hypothesis? To know this one, what does it say? Let's look to the speaker notes. Use the box at the bottom of the front of handout 4.4 to determine whether to reject or to fail to reject the null hypothesis. So let's go to 4.4, and it says on the bottom, if the p-value got is less than or equal to the significance value, reject the null hypothesis, and if it's greater, failed to reject the null hypothesis. So let's take a look. We have 0.05 as our significance. We have 0.00002. So 0.00002 is less than 0.05. So we are going to reject the null hypothesis. And that is actually good. You want to reject the null hypothesis. That's all you're going to do in this slide. Okay, so now in this last slide, this is stating your conclusion in context. And so basically, if you look at the speaker notes, it tells you how to do it. So at a significance value of 0.05, now we look to blank 1. Is there or is there not enough evidence? There is enough evidence to reject the null hypothesis. That's what we basically found out in the previous slide and make a decision. Based on this, I can conclude that my hypothesis, and here we're going to restate our hypothesis. Okay, our hypothesis is the average number of pairs of shoes a student at MHS owns is less than 6 is true. And I believe that I fixed this to likely true because, you know, again, with the convenience sample, it's not, we don't really, it creates one of those, is your sample really representative? Those kinds of issues right there. Okay, so that is basically a walkthrough of how you use this information that you're given to do your hypothesis test lab. Again, I really strongly encourage you to take a look at your copy of the slideshow that I shared out this morning or on Tuesday the 1st, because this slideshow is almost identical to that. So we'll do maybe another example of going through the slideshow so you can understand how you're going to do your lab. And if you just stick with me, you look at those notes, you follow the speaker notes step by step, go through it, taking those steps, I think you guys are going to be fine. You got to work with me. You got to have the persistence to kind of persevere through it. And I know you're going to do great. Please work on collecting your data for your experiment. Be on the lookout for when the due dates are with regard to your data collection, with regard to when the final project's due, because I really want us to be able to wrap this up, do another little mini unit, and then really that'll put a nice little bow on the year. Wrap that up. All right, so thanks again, folks, for watching. Again, stick with it. Feel free to send me any questions. I'm always happy to answer any questions you have. Best of luck. Have a wonderful day. And don't forget to love math.